All right, this is Fall Exam Review Worksheet 5, and we're going to be looking at some miscellaneous multiple choice problems, but try to focus mainly on calculator portion problems. Okay. Start with number 1. We have a first derivative of a function that's given, and on the interval, how many relative max does the function have? So we can use our calculator to graph this derivative function, and the graph will look something like this once you plug in the calculator. Okay. The important thing is that to be able to interpret your f prime graph, right? Keep in mind you're looking at your f prime graph. And so the x-intercept represents where the slope is 0. Anything above the x-axis represents where the slope is positive. And anything that's below the x-axis represents negative slope, okay, or where the graph will be decreasing. Okay. And it helps if you can create a sign line based off this information. So in your graph, we see that we have 1, 2, 3, 4, 5, 6. We have 6 critical points. So I just put those points down here. In this first region, we see that it will be below the x-axis. We know the graph will be decreasing. Above the x-axis, increasing slope. Below, decreasing. And it just keeps going back and forth until we reach to our last interval before 8. Okay. So basically, wherever slope changes from a positive to negative is going to be where your maximum, where your relative max will occur. And it helps if you can draw the arrows, because then you can visually see that we're going to have a relative max when graph goes from increase to decrease. Okay, so we have 3 relative maximums. Okay. Number 2, let f and g be differentiable functions on the interval from 3 to infinity, such that g prime is equal to f of x on x minus 3. And f of x is greater than 0 for all x greater than 3. Which of the following must be true? Okay. What we can do is we can first realize that we're looking at a derivative function. Okay. And the answer choices are all asking about relative extrema, relative max, relative min. And if we want to find out information about relative max, relative min, we need to find critical points and kind of have an idea of what this graph looks like. Right. This is already a derivative graph, so if we want to find critical points, we can just set this derivative function equal to 0. So g prime of x is simply going to be f of x, natural log of x minus 3. We haven't changed anything. We can set both equal to 0 to find critical points, f of x equal to 0, but they already tell us that f of x is always greater than 0. Okay, we're not going to have any critical points from here. However, from natural log of x minus 3, we can set this equal to 0, and we can go through steps and solve, right? Natural log of x minus 3 equals 0. We can think of natural log as log base e. So convert this to exponential form. E to the 0 is equal to x minus 3. And then we can solve for x, right? E to the 0 is just 1. Add 3 to both sides, so 1 plus 3 is equal to x. Okay. Now, this is what natural log of x minus 3's graph looks like, right? It's basically just natural log of x, but with the graph being shifted to the right 3 units. So what that means is the asymptote was initially at 0, but then we move it 3 units to the right, so that'll give us vertical asymptote at x equals 3, and we know that the x-intercept will now be at 4. Okay, everything gets shifted over 1 unit. So now we know the critical point is at 4. Starting vertical asymptote is at 3, so we know that this is what our graph will look like. Okay, with vertical asymptote at 3, critical point at 4. Now we need to figure out the slope in each of these intervals. Okay, let's look at 3.5. Okay, so plug 3.5 into the derivative and see whether we get positive or negative. F of x is always positive, so we can ignore that. Natural log of 3.5 minus 3, right? You either look at the graph realize that this is a negative region, or you can do natural log of 0.5 minus 3, which is natural log of 0.5, and natural log of 1/2, it's just going to be a negative value. So we know that in this region we'll get a negative slope. In this region we'll get a positive slope because we can plug in 5 or 6 or 7, and all these values you can tell by the graph will be positive above the x-axis, or you can see natural log of 5 minus 3 is 2, and that will give us a value above the x-axis, so positive. Okay. And then based off of this, we know that we're going to get a relative minimum at x equals 4. Okay. Number 3. Let our function be differentiable, which is a smooth curve on the open interval from 0 to 5. We have all these ordered pairs. Which of the following must be true? So it helps if we can sketch the information that they provide for us, and then we can visually convince ourselves what the answer is. Okay. F of 1 is 2, I plot that point. F of 3 is -1, I plot that point. F of 4 is 5, plot that point. Which of the following must be true? For 1, it says for some value where c is between 1 and 4, f prime of c is equal to 1. So this is talking about mean value theorem, right? Is the average slope going to be equal to it's going to be equal to the instantaneous slope at a point. Okay, and if we find the average slope, then we can determine that information. So between 1 and 4, that's just finding the slope between the endpoints. So my ordered pair is 4, 5, and 1, 2. So I find the slope, find the average slope, and that's going to be equal to 1. So because the function is differentiable, so because differentiable, we know it's also continuous. So continuous and differentiable, and we can guarantee that the instantaneous rate of change is equal to the average rate of change, which we found to be 1. So this is true. Okay. For number 2, function has at least 3 zeros on the interval. So not necessarily, right? If we just graph like this, we're only going to see 2 zeros. So this is not necessarily true. For 3, between 1 and 4, f of c is equal to 4. So are we guaranteed that there's going to be a y value of 4? And that will be guaranteed because we see that we have y value of 2 here, we have a y value of 5, and through the intermediate value theorem, because it's continuous, we know that the y value has to cross 4 some point between the endpoints. So through intermediate value theorem, we know that's true, so only 1 and 3 will be true. Okay. All right, number 4. Base of a triangle is increasing at a rate of 2 centimeters per minute, and the area remains constant. What's the rate that the height is changing? So we have to think about the area formula, which is 1/2 base times height. Okay. Let's look at what they give us. Base of the triangle is increasing at a rate of 2 centimeters per minute. Increasing, so we know it's a positive rate, so I say dB over dt is 2 centimeters per minute. Area remains constant, so that gives us a hint that dA dt is going to be 0 square centimeter per minute. Okay. We want to find the rate at which the height is changing, so dH dt. So let's apply product rule because we have 2 variables here, because we're trying to get to dH dt. So dH dt is equal to f prime g plus f times g prime. And then we plug all the information in. 2 replaces dB dt. We don't have h, so we'll have to hold on to that variable. We don't have b, we'll hold on to that variable. dH dt is what we're looking for. So really we should have to solve for dH dt. Okay. The 2's cancel out. Subtract h from both sides. Divide both sides by b over 2, which is the same thing as multiplying by 2 over b. And so we're left with negative 2h over b centimeters per minute. Okay, number 5. This is simply a limit problem, but we can actually if you try to plug in c in for x, you'll get 0 in the denominator, so we're going to have to go through factoring. Okay. Here's a hint here. This is difference of cubes, so we can apply difference of cubes to the numerator, and then difference of squares to the denominator. That will allow us to cancel out one of the factors, and then we can replace the remaining x's with c's and determine what our limit is. So We get 3c squared over 2c. The c's cancel out, so we get 3c over 2. Okay, finally, number 6. Side of the square is increasing at a constant rate of 0.2 centimeters per second. So that's ds dt. In terms of perimeter, what is the rate of change of the area of the square? So we're trying to find dA dt. So we need a couple pieces of information here. We need to know the area of a square, which is s squared, side times side. And then we also need the perimeter of a square, which is 4 times s, right? S plus s plus s plus s. Okay. dA dt is simply going to be 2s times ds dt, so we find the derivative. We know ds dt, which is 0.2, but we have to represent our answer in terms of perimeter, so we need to replace s in terms of p. We know p is equal to 4s, that's a relationship. So if we solve for s, s is p over 4, so replace s with p over 4, multiply this out, and we're going to get 0.2 divided by 2. Okay, 0.2 divided by 2 is the same thing as, well, basically 1/2 of 0.2, which is 0.1 p square centimeters per second.